Hello everyone, welcome to the week 11 of this course. So we were talking about various applications, and this week we will focus on two different applications, text summarization and text classification. So this lecture we will start talking about text classification, and we will focus on one very important approach, that is using LexRank algorithm for summarization. So what is text summarization? So text summarization, as the name would say, is that you have a lot of information with you and you want to produce a summarized form. So you want to summarize this information to some reasonable extent. So you are trying to distill information and you are trying to present only a summary out of that. So there are some definitions that you can find for this task of text summarization. For example, so then in Harvey in 2008 gave this definition. So a summary is a text that is produced from one or more texts that contains a significant portion of the information in the original text and is no longer than half the original text. Okay, so what do you see here? So you have some initial data, text data. It can be some documents, one document, set of documents, or whatever, and that contains some information. You want to convert that into some different form. So that will be again text, but now it is much more smaller than the original data. So it can be maybe half or even 1/4 of the original data. What is important is that it should contain the the important information from the original text. So you want to retrieve the original important information from there and try to compress otherwise. That's the goal of summarization. So we can also give this definition, that is the process of distilling the most important information from a source to produce an abridged version for a particular user or task. So it might happen that you need a very generic summary, or it might be for a particular user or a task. So that is also possible in the case of summarization. So now, when we talk about summarization, so you might have written summaries yourself in your school days and all, and it is said that humans are generally very good in doing summarization. So they can not only reduce it to half, 1/4, you can also go down to the very critical bit. What is the actual information that is there? So this is like a Calvin Coolidge. So he heard a lecture for 4 hours on a clergyman preaching on sin, and somebody then asked what did he say. So he can mention that in one bit, that that person said that he is against it. So this is like condensing this information to the very critical bit. So humans are very, very good at that. But what about the machines? So what can machines do? So how can they achieve a summary from a given text? So when we talk about automatic text summarization, so we are talking about an algorithm or a system that will take an input as a document or set of documents, and for a task it will produce a summary out of that. So the goal would be to give an overview of the original document in a shorter period of time. Okay. So we can see this definition with these different applications of summarization. So for example, you are seeing, suppose you want to read certain research article or news article. So it would be good if somebody can present a short summary of that news or research article, and then you can make your mind, okay, whether I want to read this whole article or not. So in scientific articles you get the abstracts as the summary. So abstracts tell about what do you see in this research article. But news articles you have only headlines but may not have the abstracts. So suppose you take a news article and produce a summary of what is the main information that is contained here. That can also help you in saving time if you want to read a lot of different articles, or it can also help you understand whether you want to read it in more details. Then you can talk about summaries of email threads. There are email threads between customers and different agents for a particular product. It can be about a particular research task that you are having a lot of conversations. You want to find out what are the important points from this big email thread. You can talk about summarizing meeting minutes, yes, action items from a meeting, or you have a lot of sentences and you try to combine them and compress information from there. So there can be many different applications here that you can think of for text summarization. Here is one application that you see like daily, that is generating snippets from the web pages. So you are searching from something, you get some results, but with the results you also get some snippets. Okay, so like here in the news, Robert O'Neill taking credit for killing Osama bin Laden sparks debate. So this is from a old news article, and with that you also see a snippet from the news. Similarly, if you do some search, what's the relation between pressure and velocity, you get different results, and with some results you can also get the snippet that is relevant to the question that you will have asked and contains the important information from the document. So this is another very important application for text summarization. Now when we talk about summary, there are different genres in which you can produce summary. Okay. So for example, you can talk about building in extractive summary or in abstractive summary. So let us try to understand the difference. In extractive summary, you will take the input document that and you will break it into say various sentences, and you will try to pick up what are the important sentences from here. So you are extracting information from there. So you are extracting some segments from there. But in abstractive summary, you will also take important information and rewrite in your own words, and you will merge different sentences, fuse them together, and so on. So in extractive summary, you are listing fragments of text. On the other hand, abstractive summary, you are taking content and rephrasing that, so that it becomes much more readable. So when you write a summary, you are probably doing it in an abstractive manner. Then you can have a single document summary or a multi-document summary. So you have a single news articles, or you take multiple articles that are belonging to the same theme, and you are producing a summary out of that. So both are possible. So this is based on one text, and this is fusing different text together. It can be a generic summary from the input document. So what is the generic view of the document, or it can be a query focused summary. That is, you have a particular query and you want to get a summary that is focused on your particular query. So the document might contain many different informations, but the information that is close to your query, that will be summarized. So you can also think it as a complex question answering task. You are asking a question, the information is there in multiple documents, you find out the information and reply to you based on what is relevant to your query. So in our next 2-3 lectures, we will mainly focus on extractive single document and generic summarization. So we'll talk about how do you take a document and create an extractive and generic summary out of that. But whatever method we will discuss are very easily extendable to the other forms like multi-document summary and query focused summary, and also for abstractive summary we will give some discussion that how do you use this method for generating an abstractive summary. So let us focus on the simplest aspect that can help us to talk about only the fundamentals, that what are the different algorithms or hypotheses that you will use for constructing a summary from a given input document. So when we talk about summarization, what are the main stages that one needs to go through? So firstly, you are given an input document. First task would be you will try to select the content that is important for summarization. So that is, find out what are the most informative sentences from here. So if I am talking about extractive summarization, find out important sentences from this document. So we will see how do we design an approach for finding the important sentences. What are the different hypotheses I can take. Now once I have selected the content, I know these sentences are important. What would be the next task? Next would be I will try to order them somehow. So whether this sentence will go first or this sentence will go after this. This also depends on how will I make it more readable or more presentable to the end user. There I have to talk about okay how it can be more coherent and so on. Then I might want to simplify the sentences that I am getting from the actual summary. That is, I want to remove some of the redundant phrases and so on. This is like simplification. Once I have done that, I may also want to remove the redundancy. That is, I found out what are the important sentences, but there two of the sentences are very similar to each other. So I want to remove a sentence that is similar to some of the sentence that is already present in my summary. So I do not want to give the same information multiple times because I have a shortage of space. So whenever I talk about summarization, I generally put a restriction that I want for a document, I want a summary of length 100 or length 200. So I do not want to waste space by giving the same information multiple times. So this is like getting also diversity in the information. So when we talk about the most basic algorithm, this will only concern the first part, that is the content selection. How do I find the most important sentence in the document? So let us see what is the simplest algorithm. So this was designed by Learn in 1958. This is called unsupervised content selection. What is the idea? Choose sentences that are very, very informative. And that how do you realize the sentences that are very informative? So find the sentences that are having very salient or informative words. Sentences that are having very informative words, choose those. So immediately the question is, okay, for doing that, I need to define what is the information contained for each of the word, and given sentence, I can add the information for each of the words. So how do I assign the information for each of the words? So what are the simple measures? So one simple measure is you take a TF-IDF for each word. So for each word in the document, in the sentence, you find out what is the TF-IDF weight. We already discussed how do we compute TF-IDF weight, and then take an average TF-IDF for the whole sentence. Second approach would be you define what are your topical words, what are your content this domain specific words, and then take sentences that contain more of these topic bearing words. So that is, you define something like a topic signature, and you choose a smaller set of words that are specific to that domain, and weight of word WI can be 1 if WI is a specific term in that domain and 0 otherwise. So that is, you are talking about politics, you know, okay, there are certain terms that are very important to this domain to politics, and they are called topic signatures for this domain, and whichever word is in this topic signature is given a weight 1, otherwise 0. So now once you have defined a weight to each of your word using one of these methods, you find the weight of your sentence by adding the weight of each individual word and dividing by the length of the sentence. So that is what is the average information of the words in this sentence. So you take the information for each of the word and take an average. And this is a very, very simple method. It does not see what are other sentences in the document and anything else. It just assigns the information to each of the word independently and takes the important sentence by this method. So this is a simple method that you can use. But what is much more principled method and much more common method is something called a LexRank method. This is coming from this is like a graph based method for summarization. So what is that approach? So this flowchart kind of explains this whole approach. So let us try to understand this. So I have an input text document that contains a set of sentences. So like here you have a sentence like computation is a process following a well-defined model and so on. And second sentence, a computation can be seen as a purely physical phenomena and so on. So you have a set of sentences here. So what is the first step? You find out what are the individual sentences here and provide their TF-IDF weights. So you say, okay, sentence S1 contains the word computation with a TF-IDF weight of 0.1, process with a TF-IDF weight of 0.15 and so on. Sentence S2 contains computation with a weight of 0.1, seen as a weight of 0.05 and so on, and I will do it for all the sentences. Okay. So this is like I am converting this document to a machine readable format where I have different sentences. Each sentence has some words with their different TF-IDF weights. Now once I have done that, what is the next step? Now I treat it as a graph where all these sentences are the nodes in the graph, and edges depend on what is the cosine similarity of different sentences in this the pair of sentences. So what I will do now, I will take all the sentences in my document and I will construct a graph where these are the nodes and the edges are what is the similarity between every pair of sentences. So S1 and S2, how similar they are. So this graph is again very easily constructed because you already know what is the representation for each sentence. So you can compute the cosine similarity to get the similarity between two sentences. Now once you have this graph, then you use a hypothesis for getting the important sentences. And what is the hypothesis? That is the most important part here. So the hypothesis says that when you're talking about a document, so it's a news document or a research article, it's about a theme, right? You have an underlying theme there. Now sentences that are important to the document should be talking about that theme, and because this theme is prevalent, this sentence should be similar to many other sentences in the document. So that is, a sentence that is similar to many other sentences should be called as the important or the relevant sentence, and this is the main hypothesis that is used here, and these other sentences should also be relevant. So sentences that convey the theme of the document are more similar to each other. Okay. So now this can give us a nice intuition on how do we construct an algorithm. Sentences that are talking about the theme of a document are similar to each other. So I am saying a document is or a sentence is important if many other important sentences are similar to this. If it is similar to many other important sentences, and that if you try to think of this hypothesis, that is very close to what we do in the case of PageRank algorithm. So in PageRank we say that a web page is important if many important web pages link to that, and here we are saying a sentence is important if many important sentences are similar to that. So that means similarity we have to somehow link it to incoming edges, and so we directly convert that to some sort of a PageRank algorithm. So what do we do there? So we construct a document graph with sentences as the vertices. That is easy. I know how many sentences are there, that many vertices I construct. Then I compute the similarity between sentences, and I construct some sort of a matrix. So I can compute similarity between S1 and S2, S3 and S4 and so on by cosine similarity, and then I have a matrix format of all the n cross n pairs. If there are n sentences in my document, I have a matrix of size n cross n that stores how similar each two sentences are. Now once I have this constructed this matrix, I want to apply a PageRank kind of algorithm to compute the informative score for each node. So that is, I want to compute the sentence centrality vector I, and I has as many elements as the number of nodes. So I will have a score for each of the node, and the node that gets the highest informative score has the highest PageRank, or is this one that is selected first. So let me try to spend some time in discussing what is the rationale for using this approach, and how do you actually apply this algorithm. So what you are doing here, so you are constructing this matrix A, that is how similar two sentences ij. So the element ij will tell me how similar two sentences ij are. So this is an initial matrix. So now to be able to apply PageRank algorithm, you need to convert that into a row stochastic matrix. So convert that to a row stochastic matrix. What do I mean by a row stochastic matrix? Such that all the elements in an individual row add up to 1. So, and how do you do that? You will take all the elements, sum them together, some get a addition, and divide it by the summation over all these elements, and that will ensure that all these elements add up to 1. So summation of all these elements will add up to 1. Now how does that help? So there we need to understand what is the intuition for, and this is called the m tilde here. This is my m tilde, that is the row stochastic matrix. Now what is the intuition of adding this to 1? So adding to 1 gives me some sort of feel of probability, right? So how we can see these entries as probabilities? So now this m tilde ij will be the probability with which you are going from node I to node j. So that is, assume you are having a graph, node I, and there are all other nodes, node 1, node 2, node j, and node n, up to on node n. So idea is that you are doing a random walk on this graph. At some point of time, you are at node I. From node I, you can go to all these nodes. So there is a probability with which you can go to different nodes. So that is m tilde I1, m tilde I2, m tilde Ij. There may be some probability of it staying here, m tilde II also. Okay. So there is some probability with which you can go to different nodes, and so you have a distribution, and you will sample some node, and you will go to that. And suppose you go to node j, then you start from there. So this is a random walk that you do, and when you do this random walk, it converges to something like v is equal to vm tilde. Okay. So v is the actual page rank vector that you are obtaining from there. So here, so in page rank, what is important? A node, a web page is important if many important web pages link to that. So that is, I have a node I. It is important if it is getting in links from many other important pages. So this is important, this is important, this is important, and it is getting in links to many of these pages. And how do they correlate? So because you are getting in links from many important pages. What does that mean? So the translation between this random walk and this page rank value is, a high page rank value indicates that if you do a random walk for sufficiently long number of time, you will stay on that node for a larger fraction of time. So suppose this node has a higher page rank than this, that means if you do a random walk for large number of time, this node, you will stay at this node for longer time than at this node. So now if this node is linking to this node a lot many times, what does that mean? Because you will be staying at this node for longer times, and from here you have a good probability of reaching to this node, so accordingly you will also stay at this node for a longer time. And if you have it from many important nodes, that means there is a high probability that you will be staying at this node for a longer number of times. So that is, if a node gets incoming edges from many important nodes, then it has a high page rank. Okay, and that is formulated by this simple equation. So that is, if I want to write it as an equation, I will say importance of this node I would be, importance of node I will be, if I write it crudely, I will say will be proportional to importance of all the other nodes j that are linking to it, and the probability with which they are linking to it, times m tilde ji. Okay. So ij times m tilde ji, and I will sum over all j, and you will see that this will actually take it to this formula, v is equal to vm tilde, and that is my page rank algorithm. Importance of a node is importance of all other nodes that are giving an incoming link times the probability of going from that node to this node. So how high this incoming link is. So and then you iteratively compute these all these I values, and there is a very simple formula for computing these iteratively, and what is that? So we know the equation is v is equal to vm tilde. Okay. So how do you compute it? You start with some initial v0 and keep on multiplying with m tilde. So v t naught m tilde is your v1. Then you do v1 m tilde. Okay. So this will be like v naught m tilde square. Then you got, this is your v2. Then you go v2 m tilde. Keep on doing that. Now what will happen? Because this is my equation, it will converge at some time where Vt, that is Vt minus 1 m tilde is very similar to Vt minus 1. So that means now Vt and Vt minus 1 are roughly same, and this is your actual equation. So it will converge at some time. So you keep on multiplying with m tilde at some point of time, and at every time you keep on finding the difference, Vt minus 1 minus Vt, find out the difference. At some point of time this will be below a threshold, at that time you will stop, and whatever Vt minus 1 or Vt you get at this point, this becomes your page rank. Okay, and that's how you compute your page rank. So now we saw what is the rationale of using page rank and how do you compute page rank. But now if you go to the actual formula, this looks slightly more complicated than what we were seeing. Now this is similar, right? Ij is equal to summation over ik times m tilde kj, importance of k and the probability of going from k to j, summation over ik. But you see something like a mu and 1 minus mu divided by s. So let me see what is this mu and s. S is the number of sentences here, and mu is something like a small teleportation probability, teleport probability. What is the idea? Suppose in your whole graph there is a node I that has some incoming edges, okay, but there is no outgoing edge from here. So there is no outgoing edge. So when you are doing your random walk, once you come to node I, you cannot go back. You cannot go to any other node in the graph, and your random walk is stuck. And this creates a problem in defining the steady state probabilities and all that. So that's why you say, okay, from each node I will assign a small probability to all the nodes. Okay, so this probability is nothing but 1 minus mu. You equally distribute among all the s nodes, divide by s. So there is a probability 1 minus mu divided by s for going to all the nodes, and there will always be a self probability 1 minus mu divided by s. And to balance the probabilities, you multiply plus mu and the actual probability m tilde ij. Okay, suppose this was m tilde ij initially. Now the probability becomes 1 minus mu divided by s plus mu m tilde ij, and you will see that now the probabilities will still add to 1. And that's the only thing that you are seeing here. So ij is mu times this plus 1 minus mu divided by length of the sentence. So now if you take, so in general the value of mu that you will take here is roughly close to 0.85. That is a common general value. So if you take mu is equal to 0.85 and try to run this algorithm, so I'll encourage that you try to run this algorithm, you will find that these are the page rank values that you will get for these 5 sentences. Now how would you pick a sentence from here? You will take the one that is having the highest score. So we will take the sentence S4 first. Then if you want a longer summary, then you will take S1 further longer, then S3. More than that it will not be a summary. So we will take S4, then S1 and S3 if required. So this is how you will construct a summary. That is the first part of content selection. How do we select the important sentences from the document? Now, so there will be one problem here, that is, suppose I select the S4 sentence, but S1 is quite similar to this, but this is coming out to be relevant as per this approach. So I want to give some less weight to a sentence if it is similar to some already existing sentence in the summary, and that's why I can do some sort of diversity, and I'll quickly tell what will be an approach that you will use for diversity, and this is called the maximum marginal relevance. So given something is already in the summary, how much more relevance you are bringing in by the new sentence. So this is like an iterative method for content selection from a selected list of important sentences. So what is the idea? You iteratively choose the best sentence to insert in the summary that is minimally redundant with the summary so far. Okay. So informativeness of the sentence will be among all the sentences in the document, informativeness of the sentence minus lambda times similarity of sentence with the already existing summary, and whichever gives the highest informativeness is included in the summary. So what is the idea? So suppose you have the sentences with with this informativeness 0.3, 0.22, 0.2, 0.18 and say 0.1. Okay, informativeness of 5 different sentences. So you took this sentence for your summary. Summary contains this sentence 1. Now, as per the relevance, you will take sentence S2. But what this approach says, okay, now you again re-rank them. And what is the criteria? This would be informative score of a sentence S minus lambda times similarity of S with the summary. So that will be 0.22 minus lambda times similarity of this sentence with this sentence. Okay, suppose it comes out to be lambda times similarity, this whole thing comes out to be 0.05. So this becomes 0.17. You will do that for all the sentences. Suppose it comes out to be 0.17, this comes out to be 0.18, this comes out to be 0.15, this is 0.08. So then you will again sort them and take the one with the highest value as per MMR, and this goes to your summary. Now your summary has 2 sentences. Again you will compute this informativeness minus lambda times similarity of this sentence with all the sentences in your summary. Okay, you will again rank this, this and this, and you will try to take the one that is having the highest score as per MMR. And you will do that iteratively until you have got the desired length of your summary. And that is the idea of taking redundancy. So you can see that how we are helping. So initially I would have taken this sentence followed by this sentence, but this sentence is very similar to this sentence. So this approach helped me to choose another sentence that is not so close to the original sentence. So you are also having the diversity now. So this was one approach for doing summarization. So in the next lecture we will talk about another approach for doing summarization, that is based on some sort of optimization. So see you then.